Hello, my name is Nico, and this is my Lab 5. So, for the introduction of our Faraday's Law, we were to examine how a magnet would be falling through the tube of aluminum foil, and then we would see how long it would take to fall out. We would then use GlowScript to show the computational model, and then we would compare the average time from our experiment to the average time of the computational model. So, some key concepts and equations that we would be using are Newton's second and third law. We would be using the action reaction forces within these laws, and then we would also be using the Biot-Savart law when we are finding the magnetic field acting from on the tube. And we would also find Faraday's law, and we would find the change in flux to see the current that was induced on the tube. We would also be using Ohm's law and the momentum principle. So for our procedure, we were to obtain a conductor. In this case, it was the tube of aluminum foil. Then we were to find the north pole of our bar magnet, and we would then position it to where it would be at the top of the aluminum tube, and then we would then record the video of our magnet dropping through this tube, and then we would find the average time it took to fall through the tube for the magnet. In this case, mine was 0.228 seconds, so it was very fast. So for our glow script code, we were just to find the initialization of it, and then we were creating the tube of the aluminum foil in this screenshot right here. And as you can see, we've got our characteristics. So we have the length, the width, the radius of our tube. And then in this part, we have two screenshots of our glow script code, and we were finding the magnetic flux, and we were also calculating the gravitational force of our magnet. We were also finding the net force, and then we would update the position and velocity of it. And then for our glow script, we have our time that it took to fall, which was 0.262 seconds, which was relatively slower than our experimental time of 0.228 seconds. So for our reflection questions, what if the resistivity of the conductor were reduced as close as possible to zero? Well, if the conductor resistance was reduced to zero, then the current in the aluminum foil tube would increase. And this means that the induced current would also be higher in the middle. However, whenever we plug this into our equation, we would also know that the force would be larger, which means that the magnet would also take longer to fall. So therefore, it falls at a slower rate. What if the holes or slots were cut into the tube, and how would it affect the ring currents in our model? Well, the induced current wouldn't really flow through these areas as much because there's less rings. Therefore, it causes the magnetic force on the bar to decrease, and it causes the magnetic to fall faster.